A horizontal pod autoscaler, commonly known as an HPA, is essentially a helper component which is attached to a scalable controller like a deployment or a replica set. An HPA monitors the resource usage of the target controller's pods and scales the number of pods based on its observations. An HPA is composed of two components, an object and a controller. The controller is basically an infinite loop which periodically changes the number of replicas for a deployment or replica set based on observed metrics. The HPA object determines the behavior of the HPA controller. It specifies things like the target controller and target resource usage value. The target controller is usually a deployment or replica set to be auto-scaled. The target resource usage value is the metric that the HPA should scale by. The HPA will observe the pod's recent metrics and scale the number of pods up or down so that their metrics meet the goal.
Here's the scenario. Most of your team is building a web server that's going to host your company's flagship product, codenamed Zeus. You have been tasked with setting everything up in Kubernetes. Your boss is particularly interested in having Kubernetes automatically scale the server up and down based on real-time demand. Of course, you're going to use a horizontal pod autoscaler to meet these requirements. At this point in scenario land, the web server is still being developed. Therefore, the first thing that we need to do is create a mock server to test our Kubernetes components. When the rest of the team finishes building the web server, we can swap it out with the mock server. Here is the mock Zeus server, which is written in Node.js and Express.js. Whenever the server receives an HTTP GET request, it squares the index I 1,000 times in a row. This simulates a mildly taxing CPU task. Note that this mock server is bundled in the true Kubernetes / CPU bound server Docker image, which we will use in the following examples. Now let's go over the Kubernetes config files for the Zeus project. Here is the deployment config file for the Zeus server. The deployment has a single replica which runs a CPU-bound server container. Next, we have the cluster IP service for the pods which are created by the deployment. All requests will be balanced between the Zeus server pods by this service. This is the Horizontal Pod Autoscaler config file. Scale target ref has fields which specify the target controller that this HPA monitors and scales. The nested API version, kind, and name fields all need to match the corresponding values found in the target controller. The max replicas and min replicas fields specify the upper and lower bounds that the HPA can scale the target controller to. In this case, the HPA cannot scale below 1 replica or above 8 replicas. The metrics field and its subfields are how you specify the desired usage metric that the HPA should aim to maintain. Broadly speaking, there are two general types of metrics: resource metrics and custom metrics. Resource metrics are things like CPU and memory usage. They come standard from the metrics server. Custom metrics can be whatever you define, like packets per second or requests per minute. They require a more advanced metric server, like Prometheus, and are outside the scope of this course. Looking back at the metrics field, you can see that the type is resource, meaning that the HPA targets CPU or memory usage. If the value were pods or object, then the HPA would target some custom metric instead. In this example, we are targeting CPU usage with a desired average usage value of 100 millicpu. Stated another way, the HPA should scale the number of Zeus server pods up or down so that their average CPU usage is 100 millicpu. Now that we've covered the background material, let's create those three components. When we describe the HPA right after creating it, you'll notice that the current pod metrics are not yet known because there hasn't been enough time for the metrics to accumulate. That's what all these error messages are telling us. Okay, Enough time has passed for the metrics to have accumulated, so I'm going to describe the pod again. Notice that the metrics field is telling us that the Zeus server pod is currently not using any CPU. This is because no one's making any requests to it. We need to create a pod which will simulate users making requests to the server. Here is a simple pod which I call load generator. All it does is use the curl command to make a GET request to the mock server. It does this in an infinite loop to simulate a lot of demand from a large number of users. Let's create the load generator pod. Then I'm going to watch the pods. See those new Zeus pods? They were created by the Horizontal Pod Autoscaler. When I describe the Zeus deployment, you can see that the average CPU utilization is roughly 100 millicpu, which is the target that we set for the HPA. Furthermore, when we top the pods in the cluster, we can see that every Zeus pod is using roughly 100 millicpu. That's right in line with the desired CPU utilization set in our HPA config file.